Not at the moment. So this would be Chapter 1 review. We'll call it Part 2. Okay. So order of operations is 1.3, and in each one of these sections of problems, so for example, the 1.3 here, you have exercises or problems 8, 9, and 10, and they give you an example on how to do them right here. And then, of course, if the example isn't enough to help you out, they tell you what pages this is on and the fact that you can go back to 1.3. Quit the tapping, thank you, and put all that stuff away. So, for example, order of operations, what was the letters or the word that we used to help us remember what to do when we're talking about order of operations? He's not here. Mr. Leboutier, do you remember what it was called?
The order of operations, PEMDAS?
Yeah, PEMDAS, exactly. Please excuse my dear Aunt Sally. And so the first thing is parentheses. All right?
Exponent, multiplication, division, addition, subtraction.
Yep, heard somebody just say it. Parentheses, exponents, multiplication, division, addition, and subtraction. Okay, that's the order that you would do. Shh. Raise your hand if you have a comment or question. Now, let me put one up here for a second, and I want you guys to try to do this here. So, let me take that back here. So in a simple problem like that, 5 subtracting 2 times 3 divided by 1, what would you do first? Mr. Lesor.
You would do 2 times 3, which is 6.
That's right, 2 times 3 is 6, so it's 5 subtracting 6 divided by 1. And of course I just made this problem up, and you guys haven't dealt with something called negative numbers. Have you guys ever talked about negative numbers? Okay.
Negative numbers are basically where there's a minus.
So this, so the next thing you would do would be 6 divided by 1, which is 6. So we end up with 5 subtracting 6, and the answer would be a negative 1. But since I don't think 6th graders deal much with negative numbers, so since I just made that one up, it wasn't the best of choices, but it works. So I want you guys to do 8, 9, and 10. And don't forget PEMDAS. The first thing you're going to do in a couple of these problems is what's in the parentheses. So let's look at 1.4, the prime factorization. And again, they give you the page numbers right there that you can go back to if you need to. And for 11 and 12 and 13, it says list the factors or the factor pairs of the number. And actually, all I want you guys to do is just factor them out. So 28, for example, this is number 11 I'm looking at. What would be the 2 factors for 28? Ms. Warner.
8 and 4.
Okay, 4 and 8 would work. 4 and 8?
I mean 4 and 7.
Yeah, okay. 4 and 7 would work better. Anything else?
You would break down 4.
To what?
2 and 2.
2 and 2. Okay, so we're all done. We can't do anything else with the 2's. The 7's prime. 2's are essentially prime. So what would be the answer to a number 11 that I'm looking for? 2, what do you call that? Squared times 7. There you go. So that's what I want you to do with 12 and 13. And then for 14, 15, and 16, same thing. I just want you to factor them out and give me the prime factorization of those numbers. So 11 through 16, I want you to do all those the same way. Questions on that, anybody? This is all review, so you guys should be fine with it. 1.5, again, they give you the page numbers if you need help with that, and they give you some good examples. And if you remember, there was really two ways to find the greatest common factor. One way, and they give it to you right here in letter A, or example A. And you basically list out the factors, and that's what they've done there. The factors of 32 they listed here, and the factors of 76. And then all the ones that matched, they circled. And the greatest factor between those two numbers is 4. And so the greatest common factor of 32 and 76 is 4. That's one way to do it. Another way to do it, and that's the method I've preferred, and I showed you, and that's example B here, and that is find the greatest common factor of 45 and 63. And in that one, they factor them out. And so 45, it's got 2 3s, a 5, and a 7. Notice that when we're talking about the greatest common factor, they just use the factors that match. They both have 3s. Now, when you find the least common multiple, which is in 1.6, you're not worried about whether they match or not. But the greatest common factor, you need to have matching numbers. And so they both have 2 3s. Well, what's 3 times 3, or 3 squared? That's 9. So the greatest common factor between 45 and 63 is 9. So remember that. In 1.5, when you're finding the greatest common factor, they have to match. They have to have the same numbers. So let me move down here. And so these are the problems that I want you to do for the 1.5 section. And it says find the greatest common factor of the numbers. And it says using the list of factors. You can do that if you want, but I'm just going to have it say find the greatest common factor. How you do that is up to you. If you want to list them like this, example A, you can. If you want to factor it out and look for the matching pairs, you can. It's up to you.
Can't you do it with a Venn diagram?
Yeah, you could do the same thing in a Venn diagram. Yep, you sure could. In fact, I think very early on, that was one of the very first examples they gave you, was using a Venn diagram. Okay? So, and then 20, 21, 22, it says find the greatest common factor. It says of the numbers using prime factorization. Again, I'm not worried about that. Just find the greatest common factor. How you do it is up to you. Whatever is easier for you, as long as you get the correct answer. All right? And I think, yeah, no, we'll keep going. We'll keep going. I do want you guys to do 1.6 also. You'll have time today to work on this. So 1.6, it's finding the least common multiple. And you factor it out like they've done here in this example. And they list the factors you can see in the example there. And notice what they do here. 12, for example, is between the 8 and the 12 has a 3. And so they use all the 2's with the 8, and we ignore the 2's with the 12. And so we use all the 2's with the 8, which is 1, 2, 3 2's. And then only one of them has a 3, and they use it anyways. And then they just multiply them out. So the least common multiple you use all the numbers. And we did some exercises about that. So let's say there was a number here and a number here. And this number, this first number, it's a 2 times 2 times 3 times 3 times 7. And let's say this other number here is a 2 times 3 times 3 times 3 times 5. So what would this be? This would be 2 squared times 3 squared times 7. This would be 2 times 3 cubed times 5. So what numbers have the greatest number of factors? Well, they both have 2's. Which one is using more 2's? The first one. So it's going to be 2 squared times. They both have 3's. Which one has the greater number of 3's? Okay? And so this would be 3 cubed. Only one of them has a 7. Do we use it?
Yes. Yep.
Yeah, we do.
And then you have to use 5.
And only one of them has, excuse me, only one of them has a 5. Do we use it?
Yeah.
Sure do. Times 5. And so you would do those, and then you would figure out what the least common multiple, what's the smallest number that both those imaginary numbers would go into. So keep in mind that when you do the least common multiple, you use all the factors that are listed and the most occurring one. Okay, I know you do. You're just going to have to wait. All right. Questions, anybody on this? All right. So, let's go back to this. Find the least common multiple of the numbers using list of multiples. So I'm just going to scratch that out. And you want to find the least common multiple. How you do it, again, is up to you. 26, 27, 28, find the least common multiple. Again, how you do it is up to you. And then finally, it says add or subtract, write the answer in simplest form. Well, if you don't quite remember how to add fractions, we did a little bit of practice on that. So how about 2/7 adding 1/3? What's the common denominator that we should use? Yeah. Yeah, 21. And watch what I do here. 3 goes into 21 7 times. 7 times 1 is 7. 7 goes into 21 3 times. And 3 times 2 is 6. Now I just add up the numerators. What's 6 and 7? What is it? 15? No. What's 6 plus 7? Yeah. 13. So it would be 13 over 21. Okay? So I do want you guys to do 29, 30, 31. And you can do 32. So I want you to do all those problems in the chapter review. Yeah. In a moment. Questions on this, anybody? Question, hon? Go ahead.
Can you show us which ones?
Yeah, I'll put it back up, hon.
Yeah, can you write them down?
You want me to mark them?
Yeah.
Okay. Let me do that.
So I can
What color should I use?
Purple, yellow, purple, red, yellow.
I'll do purple. All right, here we go. So 8, 9, 10, 11, 12, 13, 14, 15, 16. I don't think I skipped any. I think we pretty much are going to be doing them all. '23, all the way through to 32. Yep, basically all of them. I don't think I skipped any. I might have done a couple of them, but I didn't skip any. Okay? All right, I'm going to right at 15 minutes. Perfect. I try to keep these under 15 minutes. Stop.
So we
Video.